of design and capability, the mobile networks in the background have also been changing, and actually the bigger changes have yet to come. So what we'll be talking about, it's a very quick introduction, but really talking about the operator realities today, the main challenges that the mobile operators around the world face. And it really is a global phenomenon here we're talking about. It's not just US or a European-centric industry anymore. We'll then talk about the LTE architecture. LTE, of course, is long-term evolution, which is what a lot of people know as 4G networks today, and actually will be the basis of the 5G networks in 2020, which is the next bullet point there. Really, what do we need to build here ready for that next generation of network? The industry is really looking at 2020 as the next step in the evolution of those networks. How do those networks evolve? NFV and SDN will be familiar to many people, familiar with telecom networks in general, or certainly IT networks, enterprise networks. But for the mobile industry, this is an evolution that's really happening right now. And then I'll just go one summary slide, kind of put it all together, and then I'll be handing over to Di, tell you more about newer DB solutions. So the main operator drive here is we've got to monetize some of these new services. And if you look back in time, in the last 20 years, and actually back even to 3G, when we were a voice-centric industry, every additional minute of voice we used on our phones resulted in an additional dollar of revenue, or euro, or pound, or whatever you want to use. And so the more minutes you used, the more you paid. Then we had texting came along, and the more text you sent, the more you paid. When we got into more of the 3G data, we started getting some of these unlimited buckets introduced, which were really a way to encourage people to get out there and use more data. And at the time, of course, what you could do with a mobile phone was actually fairly limited in terms of bandwidth. But then along came 4G, LTE, where the bandwidth available to the user now was infinitesimally higher and continues to increase. So today, watching video on a smartphone is perfectly reasonable, and many people do it, my kids included. Tethering your tablet to your smartphone through Wi-Fi and then using the LTE connection to download a movie is a perfectly reasonable thing to do. So what's happened now is the bandwidth, of course, is increasing almost exponentially. Just as an example, in the US, in the next 4 years, the amount of bandwidth used on mobile data networks, and that's not including Wi-Fi, that's just the LTE and 3G networks, will go up about 9 times. In other parts of the world, the growth is even higher. So everybody's using more data. It's not just a few people using more data, it's everybody. But at the same time, the red line there, the revenues, are not increasing at the same time. So while the bandwidth increase is going up 9 times the next 4 years, we will not be paying 9 times as much every month. We'll be paying a little bit more every month, but certainly not 9 times. So this kind of evolution here, what you end up with is this gap building. Now, when we get to 5G around 2020, some of the things that are being discussed are increases in bandwidth of 10 times what we have on LTE today, 10 times as many devices on the networks. So the gap is going to get even bigger. So the challenge for the operator here is, how do I close that gap? How do I minimize that gap? Or if I can't get my revenues up, then how do I make sure that my costs stay more in line with the revenue that I do have? And obviously need to reduce the cost of operations here. So that's the main challenge. Now, what's interesting about this chart as well is, if you took this chart to any operator in the US, they'd nod. Latin America, they would agree with you. Europe, they would agree with you. Japan, Asia. We have a global trend here and a global problem, if you like, from a mobile operator perspective. Nobody is immune from this as we look around the world. So now let's look at the LTE architecture, which is really what is being deployed today. Not every operator in the world has LTE yet. Everybody will. Most of the developed markets, there are 1 or 2 operators in each market at least. Some of the implementations are still very early. Some of them are extremely mature. So if you look at the United States, we've got some very big LTE networks, same as you do in China, Japan, and then also in Europe as well. But this diagram, I kind of joke with people that if there's one thing we love more than bandwidth in the mobile industry, it's acronyms. And we're great at reinventing acronyms. So if you don't understand an acronym, just wait 6 months or a year, and we'll come up with something new to replace it. So this chart is a little bit busy in terms of the acronyms and the naming. But essentially what we've got here, and I'll kind of run through this quickly, is on the left-hand side, we've got the RAN, Radio Access Network. The little hexagon here, octagon, it's not octagon, is hexagon, is actually the end user device. That's your smartphone or your tablet. That's connected to what's called an eNode B. More commonly, we know it as a cell tower, the base station. That then connects back into the network, and the solid purple line here is where your traffic goes into a serving gateway and then into a PDN gateway. So think of the serving gateway as the local router where your traffic goes and then is directed into the rest of the network. Serving gateway, you would have typically 1 or 2 per city, major city. Whereas a PDN gateway is the roll-up. It's the multiple serving gateways connect into the PDN gateway. So in US terms, you would have 1 PDN gateway per state. In European terms, you probably have 1 PDN gateway per European country, maybe 2, something like that. That's kind of the scale. And then, of course, your traffic goes back into the internet, goes into the company intranets. And of course, that's where you get your content from. I'll talk about IMS in a second here. This area at the top, the HSS, the AAA, and the PCRF, is our subscriber control functions. So the HSS is actually a big database that basically says Ian is a subscriber, he has access to services, he is allowed to use these services on our network. The AAA is an authentication accounting function, very similar to what you see in other networks. And the PCRF is actually the policy control function. And this actually is the entity that says, you've reached your limit on the data you've used this month, we're going to cut you off. Or you need to top up your prepaid account, you've used all your data allocation. And if you'll notice, it's got control functions down here to the rest of the network, and that's how it does that. The MME is the mobility management entity, and that's actually connected to all of the base stations. So that is what actually controls your connection as you move through the network and move from base station to base station. Very powerful entity, that one is, as you can imagine. Now, the one here that I've got highlighted here is IMS, which is the IP Multimedia Subsystem. Again, the great acronym. And also operator services up here. So what you find in this area are basically the IP services that the operator can offer on the network. So it could be an example like a push-to-talk function. It could be voice over LTE. It could be a messaging application. These would sit in an operator data center and, of course, provide services to all the subscribers through the network. So obviously this is an area where we see a lot more development in terms of new services, a lot of vendors offering different solutions in that space, and can market to the operator and deploy as an IP service. So if the radio access network is this part, this is what we call the Evolved Packet Core, and this is basically the services part of the data network here. So really 3 distinct pieces. And just to complete out the picture, this bottom area is actually 3G. The example I've got here is actually a CDMA network. So this would be an EVDO provider that's offering LTE as well, obviously. But over time, of course, this is going to diminish, and the investment today is really going into the LTE part of the network. So what do we need for our next generation of network? Now we've got this basic architecture here we're deploying. Well, firstly, we're going to support about 50% more devices. Everybody in the developed market has got a smartphone. Many people have got tablets. A lot of people are getting connected cars. We'll have more of those. But to get more devices and to get the growth going up on the networks here, it's going to be things like Internet of Things, which I'm sure you've heard of a term before, machine-to-machine communications. So what we'll see of more in the future, and we're already starting to see it in many markets, are things like monitoring of home alarm systems, video cameras for the home, or security cameras for the outside, control of things like sprinkler systems, or irrigation, or et cetera, et cetera. You can go on and on. Thermostats, of course, have been a lot in the news, and while they're certainly controlled by Wi-Fi today, you can see that there'll be an LTE component to some of these things as we get down the road. But certainly more connected cars, more applications for long-haul trucking. These types of applications are very popular. Lower latencies. The latencies in the network for LTE are around 50 milliseconds. And the discussion for 2020 is that that comes down. Some discussions are around 1 millisecond for the network to respond, which is extremely fast. And we need this for messaging, for voice over LTE, but especially for a connected car, actually. And I'll give you a very quick statistic, is at 60 miles an hour, in 1 millisecond, the car moves 5 inches. So if you're doing a connected car, kind of a safety application, some monitoring vehicle-to-vehicle communications, in the time it takes for the network to respond to the car's request about maybe information about what else is around it, that car will have moved 5 inches. At 50 milliseconds, that's moved 4 feet, just over a meter. That's plenty of room for an accident. So latency is very, very important here. The speed with which the network can respond is becoming critical. Yes, we want more bandwidth, we want more video, we want more stuff, and we want more video. There is something called LTE broadcast, which we won't get into today, but makes use of the architecture to actually very efficiently deliver large amounts of data. But the point being, we know there's going to be more bandwidth. An HD movie uses about twice as much bandwidth as a standard definition movie. And now, of course, the industry is starting to talk about 4K, which is going to push the bandwidth up even further. Seamless integration with Wi-Fi, handoff, policy, control. Wi-Fi networks are, of course, extremely popular, both in the home, in the office, and then outside, so tighter integration with that. And then caching the content as close to the device as possible. If we're going to have more video and more content, having to go all the way through the network to get that content becomes very inefficient and very expensive. So there's a lot of discussion in the industry now about pushing the content out to the edge of the network. It could be in a data center next to the base station. It could be a little bit removed from that. It could be actually on the base station itself. And there's different models that have been proposed for this. But basically the goal here is to reduce the transit for the major content, of course, make it more responsive, increase customer experience, and ultimately reduce the cost. And that brings us to the last one here, is lower the operating costs, and I mean much lower. So today, the average smartphone in the US, the average revenue per user is around $60, $65. Adding a connected car to the network, you're not going to be spending $65 a month. It's going to be a couple of dollars a month. So how can you as an operator make money on that type of application where the revenues are a few dollars a month, not tens or 20s of dollars a month? And that's the challenge. So really bringing down the cost here is really what everybody's on about. So now let's look at our LTE architecture again, and you'll notice I've added a couple of boxes here, which I'm calling a mobile content delivery server, and it's really part of a mobile content delivery network. And some operators have started to do this already, but this is essentially what I was saying about moving that content to the edge. So today, if I'm out here and I want to get the piece of video that's out in the internet, I've got to go all the way through the network, all the way out the back end to get it and bring it all the way back, which obviously is very inefficient and adds to the time taken. So by moving the content towards the edge down at the base station here, or putting it down by the serving gateway in the data center, then of course that content is cached locally, and it's much faster for me to get it and more efficient. And now content delivery networks are very common in the wired networks, obviously a very common part of the internet structure itself, but until recently have not been part of a mobile network like this. And this is what we're starting to see now. So it's this type of application that we're talking about. That content delivery server, of course, is going to be something, it's going to have database, it's going to be storage, it's going to get refreshed, it's going to have to keep up with consumer needs and wants, and of course it's going to be a very dynamic environment in terms of the content on there, what's going to be stored. So now let's talk about virtualization. Virtualization from a mobile perspective can mean a little bit different from some things you've seen in the enterprise IT world. We kind of joke in the mobile industry that we will get to major trends, major technology trends eventually. We'll just take a little bit longer than some other parts of the IT industry. So while virtualization in an enterprise IT data center has been very common for some time, really the big operators now in mobile places are just starting to get to this. So really what we're talking about here is firstly application virtualization, where the applications are separated from other apps and services actually running on the device. That's starting to happen a little bit, but mainly the focus for virtualization, and if you talk to an operator about virtualization, they're going to talk about the network virtualization here, where the packet core, the EPC, can be virtualized and run in a data center with off-the-shelf hardware. A couple of companies have actually shown mobile radio access network, the base station, in a virtualized environment where they've split the conventional base station and then run it on regular hardware. So if we look at this, what we start to see now, of course, is a lot more software-defined networking, SDN, and network function virtualization. So really what we're talking about here is the separating of the hardware from the actual software. Your hardware, instead of a dedicated piece of hardware like a traditional class 5 switch, which we always used to have in telecom networks many years ago, now replaced with soft switches. But those replace that with something that sits on a standardized hardware. It could be standardized routing hardware or a server hardware, and then the software becomes separate from that, and you get to a virtualized network. The point with this, of course, is you can have a more distributed network. You can obviously buy hardware from multiple vendors and hopefully reduce the cost of implementation. And of course, because you're distributed now, we can put the hardware when we actually need it and move functions around, and then start to get into some more of the reduce some of the operating costs. And of course, so the benefits we see from SDN and NSV in a mobile environment here are very, very similar to what you see in an enterprise IT shop. And the same reasons they went that route, you're going to see the mobile operators do this. This is already happening today. The larger operators around the world have already started implementations. It's been a discussion for the last few years, and actually investment and work is actually happening now with some of the big operators around the world. And certainly in the next 3 or 4 years, you're going to see much more of this type of discussion and much more investment. So the functional view of virtualization here, it looks a nice colorful chart, obviously, but for those of you not familiar with the mobile networks, but you know about virtualization, you're going to look at this and go, well, hang on a minute, this looks exactly like I see in an enterprise IT shop, and that's the point. So the hardware on the bottom here could be our routing function, our SDN, PDN gateway equivalent. It could be the radio access network down here, the radio itself on the tower. Then we have the virtual infrastructure manager, the network function manager, and of course the orchestrator, which keeps everybody in tune here. We have other virtual hardware, and then we've got these virtual network functions, and of course we have the physical network functions as well, and then OSS and BSS, the operating support systems, business support systems, so billing, those types of things, sitting on top of that. So again, a very traditional view of a virtualized environment. If I look at a large insurance company today, I could probably draw a similar picture. And this is what's really being put into the mobile network, so what the mobile networks are evolving to. And the point being, it's, you know, it looks like everybody else in many respects. Now, if I kind of look at this a little bit differently here, so this is the same diagram I had earlier of LTE, but I've drawn it a little bit differently. And so what I've got here is, again, on the left-hand side, we've got the radio access networks, remote radio heads, macro cell sites, the big towers, small cells here. And you can see hundreds of thousands of these being deployed in different countries around the world, of course. A large operator in the US will have around 50,000 cell towers. In China, 500,000 upward. So obviously a different scale. These all connect back into the baseband units here is the other half of the base station, but there's the serving gateway there. And this will be in a local data center, or what we used to call a central office. There are distance limitations of how far the radio can be from that data center. And we'll typically have thousands of these in a network. So if you think of the traditional central office, there's one per neighborhood, one per small town type thing. And that's what we're looking at here. A lot of old central offices are actually getting repurposed for this purpose. And then we get into the metro data center, and now we're starting to see the packet core here. So we've got the P gateway, the PCRF, and some of the other functions will be sitting in there, AAA perhaps, and parts of the HSS. And there'll be hundreds of these. So maybe 2 per state in the United States, something like that. And then a national data center will have the rest of the IP core, the rest of the EPC, some billing and business support solutions here. And there'll be probably 4 or 5 of these on a nationwide basis. But the point being here that what are we going to virtualize? In the short term, we're starting at this area here. These look like big data centers running telecom hardware. And so that's an area that's relatively easy to start the virtualization process for. In the medium term here, we get into the metro areas, and also starting to look at these local data centers. The longer term is the RAN. It's a little harder to do, a little bit more involved. So now if I look at my original diagram and look at the ease of virtualization here, then what I start to see is that, again, those IP services, that IMS area where we're offering all those different services on the network, that's one of the first areas to be virtualized. And the reality is, if you're an application or a service provider today to the mobile operators, you're going to have to offer a virtualized solution to what you do. Simple as that. The next area we'll see is the customer support area. We're already seeing that. As I said, the HSS is a large database, and obviously you've got those other servers and functions in there which lend themselves very well to virtualization. The MME is also one of the areas we're looking at. And then a little bit harder is the serving gateway and the P gateway. Yes, we'll see those, but the problem there, of course, is we've got a lot of traffic going through them. So they are very, very critical to the revenue stream for the operator. Certainly not an area you want to get wrong. And then finally, the base station, the E node B. And this will be one of the last areas to get done, not because we can't, but because there's so many of them. It's such a huge process to go through all those hundreds of thousands of sites, as we said, and move over to new hardware. So what we'll see is that some areas will have been virtualized, some areas will not over time, some geographic areas. Okay, so let's put all this up together here. So network virtualization is a great opportunity. It's also a great challenge for the vendors. From a vendor perspective, great opportunity to get in with the operators. New solutions are needed. New architectures are being deployed. The threat is, as a vendor, if you don't move quickly enough, somebody else will. Simple as that. Virtualization is already here, as I said. Operators are working on this type of architecture around the world. And the price wars here in the US actually start to hasten the virtualization. We need to get that operating cost down. In other parts of the world, of course, there have been pricing pressures for some time. Maybe it's a growth pressure. But the concept of do more with less now is very real. So virtualization and SDN are really generational shifts here. We're moving to a next generation of architecture. And of course, with SDN, we do have challenges with performance, interoperability, and coexistence with the legacy. We can't just rip out all the old legacy stuff and put in new. It has to coexist. It's an evolution and a handoff that has to happen over time. And the final thing is that with the challenge is to evolve this network while maintaining the services revenues. You can't just turn off the mobile network and turn on a new one. And certainly we're not going to be in a situation where we can afford to have an interruption of service from a consumer point of view. Competition is massive in the mobile industry, and just one slip up can lead to you losing a lot of customers to your competitor. It's absolutely something you cannot avoid. So that's a very quick view of a lot that's happening in the industry right now. So with that, I'll hand over to Di, and he can talk about newer DB solutions. Thank you.
Thanks very much, Ian. Okay, so I want to pick up on a couple of the threads that Ian's been exploring there and drill down on them and specifically talk about that in the context of NeoDB, our Scaleout SQL database, and how we're seeing through our customers that beginning to play out in this whole landscape that Ian's been mapping out over, well, not quite a decade, but close to it. Thank you, Knox. I got it. And now Ian's taking a very forward-looking, visionary perspective in what he's been talking about today. So what I thought I'd do is slightly in contrast with that is I want to focus back in on what we can do now, what is happening now. So my topics are, I want to look at what we're learning from our customers and how that maps onto Ian's vision, and then specifically what aspects, what is it about our solution, about our products, which we think are most valuable to those customers and which we're focusing on to deliver more focus to those customers in future. And I'll finish by taking a brief peek under the covers, a quick look at the architecture of what is a fairly unusual product. So to go back to Ian's picture, he talked about all the different areas of the network and all the different components and all the different opportunities in there, and he identified this area here, IMS, within services in the packet data network, as being a key area for early virtualization. And that's certainly what we're seeing in our customer base in this area, and also companies who are providing services to consumers over the network as internet general apps to download on phones, for example. These are the two areas where, if you like, I've got most to say about what's happening now. We've got some other activity elsewhere on this picture, but I'm not going to dwell on it much today. Is one, because I really can't say too much about what's going on, and two, it's relatively early days in most cases. So let's look at a couple of things I can talk about. Our first case study is a customer who is a US software company. They deploy a very successful product they deploy it on dedicated equipment in the providers' data centers, those central national data centers. But they have a couple of problems with that. One is it's very complex to manage. They need multi-site because of to provide disaster recovery, but the database they're using, which is traditional relational database, in fact it's Oracle with Golden Gate for replication, to manage that for disaster recovery and to upgrade is extremely complex. It's very expensive in terms of deploying two stacks, although only one of them is ever actually earning the money at any one time, as it were, and very expensive in terms of the complexity of the administration and the cost of the DBA time to do it. They really wanted to address that problem. And the other problem was that their customers, in line with what Ian was saying, their customers are increasingly pushing them towards a more virtual environment. They are less willing, and this is a trend we've seen elsewhere, I'll talk about it in our second case study, and it's certainly something I've seen elsewhere as well, is there is reluctance to take these appliance-like or dedicated hardware solutions. And so there is pressure on vendors into that space to provide cloud solutions, as well as, of course, advantages to do them. And that was what this particular vendor was looking for. Ease of management I talked about, better the continuous availability, not just high availability, but continuous availability, and active distribution. As I say, they were operating in one with a second DR. In order to roll this service out and to make the revenue on it that they really feel is there to make, they have to deploy this multi data center, and that's what we're hoping to deliver to them. Well, what we are delivering, as I've described, is active. Well, the third active of that, which means not just two data centers with active, i.e. with transactions updating in both places, but 3, 4, and more data centers. That's something actually we're rolling out to them, and they're expecting to take advantage of in fall this year. But it was key to them was to get multi-data center operation, rolling upgrades, get rid of that torturous upgrade process. And the interesting thing was another one, which was ease of migration, which of course is in line with what Ian was saying, which is the need to retain consistency with the legacy and not be disrupted. This played out for them in two forms. One is that because this is a SQL database, they could migrate their existing SQL application. And because it's a SQL database, the skills they've got, the tooling they've got, the processes they've got are all geared to developing, maintaining, and extending SQL applications. So for them, the SQL application is a high advantage, even apart from the fact that, of course, for some of their applications and other people's applications, they need that transactional consistency that you need from a SQL ACID database. And the second case study I'd like to look at is a European company, and they've rolled out a pretty cool mobile commerce application, but they've been piloting that in what I've called here emerging markets, i.e. small. But they need this application to really their corporate success. They need to roll this application out in multiple geographies and specifically in the major markets. Now they deploy it as an appliance, and that appliance will not economically give them the performance they need, handle the workload that they need to roll this out to the major markets, and without that they can't make a success of their product. So they came to us because, one, they needed the cloud deployment. They were getting that same pushback I talked about before against deploying appliances in the provider's data center. And secondly, they needed to scale out that performance. Just pure performance scale out is what they needed. They're interested in multi-data center, they're interested in active and all of that, but the key thing for them was just a bigger cluster that could handle more transactions, handle more connections, and handle that economically, and specifically handle it elastically, because of course, like most mobile applications, the workload is very peaky, and you don't want to be deploying an application stack that is provisioned for the maximum and is at 90% of the time you're wasting capability and paying for it effectively. So what we offered them was this ability to migrate their migrate their appliance application quite easily onto a cloud architected database, deliver that scale out. And as I said in the previous case, the ease of migration was critical for them and was critical, of course, for continuity with the existing users of that application. So very quickly, that was what our customers were telling us, that they need to go distributed for a number of reasons. Sometimes the scale out just for getting bigger more cheaply. Sometimes it's because they need to be in multi-data centers, but usually global operations is part of the equation, and they need to be cloud ready, i.e. that easy ability to go global and the elasticity of the pricing model that goes around the cloud generally. But at the same time, they were not willing to give up transactional capability that they have in existing SQL applications, and equally they're not willing to give up the skills, processes, tools, and experience that they've got, which to re-architect and to restart in a different technology would give them, as I think Ian pointed out, if you want to re-architect then for something else, yes, you can escape the strictures of scale up traditional relational databases and move on to scale out standardized hardware with a number of architectures. But what's important for our customers, what they're telling us, is this coexistence with legacy, this need to manage risk, that SQL and the skill set around that delivers for them, because it's more rapid time to market, less disruption, less risk. So I've described the challenges that we're trying to meet and we're meeting with our customers. Let's just drill down a little bit about this new ODB that I'm talking about. It's a distributed transactional SQL database, and it's engineered for the cloud. Distributed because, and I've described the use cases, and Ian's talked about some of the trends that are going to make this inevitable, that a single data center is not sufficient. If you've got 5 national data centers in a provider in a country, then you need to be able to deliver across all of those 5, or else you're going to have a very difficult infrastructure to deal with. So it's not just active, active, it's active, active, active. And it's becoming table stakes. As I say, no way to go without it, because ACID is vital and will remain vital for many critical use cases, and the cost of simulating transactional consistency and some other NoSQL databases is very high and can lead you to a requirement for very rare skills and a brittle architecture even so. So scale out, elastic, continuously available, low administration. These are the characteristics of a genuine cloud application. And if my slides would move on, I'd be a happy bunny. As I said, the key requirements for a cloud application, and what you see incidentally in the middle there, I didn't mention the scale out performance. That purple chart, which you can see the shape of, but a little more, is that's a screen grab from one of our nightly performance tests. We run them every night on the build, which is, are we imperiling in any way the performance increments that we get as we add more servers? You can kind of deduce that from the chart, that the horizontal axis is adding more services, and the vertical axis is the throughput that you're achieving with that. And you're seeing that that steep line is what we want. Steep steps is what we want to see, and we consistently look for that. But that's something that we need for our internal testing. But externally, it's just vendor benchmarks, which I'm sure most people take with a pinch of salt, and so they should. So what we do is we encourage our customers to build their own real-world benchmarks. We encourage them to benchmark their applications in use and to feed those results back to us. And if they don't get the results that we've predicted and they expect, then we've got a problem. Doesn't matter what our internal numbers say, then we'd have to deal with the real world of our customers. Fortunately, that's not been a showstopper for us anywhere yet. And the other thing is what we call no-knobs administration, which means high levels of automation. If you're going to deploy on the cloud, you're going to deploy in multi-data centers, you do not want to have highly expensive, highly distributed, highly worked, heavily workloaded DBA teams. You need to keep that to a minimum, or else your costs are going to go through the ceiling. Why is NeoDB valuable? Well, I hope I answered my own question here, which is basically conventional applications based in a single data center on dedicated servers on a scale-up stack, provisioned for maximum workload on usually dedicated, high-cost proprietary hardware, which is a high capex and high running costs situation. You stack that up against a cloud application, geo-distributed, elastic provisioning, low capex, and pay for what you eat, basically. It's a no-brainer that that's where you want to be. And if you go back even 10 years, looking at web applications, the web tier, well, that's no problem. It scales out. We wouldn't have an internet if it didn't. Application servers in the middle tier, serving up business logic, well-established, well-used. Storage servers at the back, tremendous advances in hardware and storage management over the last 10, 15 years, but whack in the middle of that, what I've called old SQL, i.e. traditional relational database servers that are the workhorses of the applications that we want to move into the cloud. They don't scale out, they scale up, and they are often dependent on highly specialized and highly expensive hardware and software to do that. That's the problem that we're cracking with our customers. The ability to preserve transactional, preserve SQL for all of the good reasons of preserving SQL, but to make that cloud ready and easily distributable. So I hope that was just a summary of what I said in the previous 10 minutes and described our customers. And that's kind of like, I could wrap at this point and go to questions, but I'm just going to take a couple of minutes, Knox, if you don't mind, to talk about how it works, because what I just described is sounds a little bit like magic. Arthur C. Clarke, sci-fi author, once said, any technology sufficiently advanced is indistinguishable from magic. And my experience is that software engineers don't believe in magic. So although I can't prove to you that NeoDB has solved that problem of distributed relational database, what I want to do is just give you a couple of images, a couple of little notes that will help you maybe make you think, okay, this is this is interesting. It's worth investigating. And if you want to take that conversation a little further, I'll be more than happy to take it. And these are just a few pointers here, maybe to frame that conversation. So what we've got is a multi-tiered architecture, management, transaction, and storage. In the management layer, the brokers and agents, they connect the nodes together and they connect clients to the transaction engines in the transaction layer. And what the transaction engines do is they conduct all of the operational workload for the clients in a shared cache, a cache that's shared between all the transaction engines and all the storage managers. This is not an in-memory database, but it is a very memory-oriented database. It's what we call a distributed durable cache. And it's obviously not an in-memory database. There's a clue at the bottom of the picture there with the database archives, but it behaves as though it were to the client. The client thinks they're dealing with an in-memory, but what's actually happening is every time there is a request for data, the transaction engine that gets that request seeks that data from another transaction engine if it's already there, or from a storage manager, and maybe the first time when the cache is warming up, they need to go to disk to get that. And every time a client transaction updates, then it updates in the cache of their local transaction engine, and that is then shared out with the storage managers and the other transaction engines. But whilst those other transaction engines are sharing that data potentially with other clients, the storage managers don't connect to clients at all. All they do, they have one job in life, which is to make sure that whatever they get in their cache from the transaction engines, they make it durable. That's all they're doing, is they're managing the durability. Correction, they have another job, they serve up the queries, but the critical job for the operation of the system, the continuity of the system, is that they make that data durable and stored in the archives. And of course, this whole thing has to be elastic. So as the workload increases, you just spin up more transaction engines and they support more transactions for more customers, more connections, more users. And indeed, if you have pre-provisioned infrastructure, then you can tell NuoDB to monitor its own service levels. And if certain benchmark queries, for example, are running too slowly, it will spin up additional transaction engines, and the brokers and the agents automatically load balance between all the available transaction engines so that the service levels are quickly restored. And then when the additional transaction engines are no longer needed, they are deprovisioned, so you're not paying for what you're not using. So there's the elasticity of a distributed system. But of course, it is a distributed system. So although I drew that picture of transaction engines and storage managers without any vertical split, you would normally expect this to be split at least once between two data centers. And but as far as the client's concerned, it's completely transparent. They talk to a transaction engine, and that transaction engine will serve up their requirements. You may see some additional latency from the network, but operationally, the distribution of this across multiple data centers is completely transparent to the user. And of course, because we're using a distributed database system, and we're running it on cloud, and we're running it on commodity hardware, we're going to expect to get failures. If we lose a transaction engine, then what we'll actually get is every transaction that's currently in flight on that transaction engine will be backed out and will be restarted on another transaction engine. The brokers and agents will load balance that across there. What you would see at that stage will be momentarily a drop in the service levels, because you might see it if you're overloading the other transaction engines, in which case the elasticity provisioning that I talked about before will kick in and deal with that. If you lose a service manager, then so long as you've got sufficient redundancy, and what I'm showing here is minimal redundancy. If you've got 2 data centers, you'd expect to have at least 4 service managers. But if you lose a service manager, all that happens is the other service manager will soldier on alone, and when the failed server comes back, then in background, whilst the system still runs, the archives will be synchronized, and again, it's transparent to the customers. So I'm going to stop now to give us some time for questions. But all I wanted to cover today was, that little box on the top right-hand corner of Ian's, which is where are people now feeling the need the pressure for virtualization, and what is happening in the NuoDB world to meet that challenge. So I'm going to stop. Knox, can I hand back to you? And do we have any questions?
Yeah, thanks, Di. We have a few minutes left, so I think the first question is for you, and that is, can I install NuoDB on my own hardware?
Oh, yes. Sorry, I'm talking about, Scaleout multi-data center. Yes, I actually run it on my laptop. You can do that, and indeed we do have customers who run it on-prem, and we do have customers who use it in hybrid cloud, where they will provision on-premises dedicated, albeit virtualized hardware, and when they have peak loads, they will provision in from a cloud provider just to cover that. They do that for economic reasons. It just makes sense to spend that money that way.
Okay, thank you. Ian, I think the next question is for you. Which aspect of your functional view of virtualization do you see experiencing the most disruption within the next few years?
So I think as one of the diagrams showed, really the way to think about this is more of the peripheral, let's call them peripheral functions of the network. So there's a lot of customer databases, those servers, the PCRF, the AAA, HSS, those types of functions obviously very critical, but if you were to see those in the data center, they look like a very traditional IT type of application. Those areas certainly getting a lot of attention right now. The IP services, as we said, and as Di pointed out, certainly a lot of attention there. Those areas I think you're seeing first. Then look at the big data centers on a nationwide basis. They've got some big routers in there, those PDN gateways, certainly the billing and support systems, operational support systems are getting attention. And then really work your way down through the network. And the last area is really going to be the radio access networks, purely because there's so many of them. Simple as that.
Thank you. And then, Di, I think the last question is for you. You've only talked about transactional applications. Can I use NuoDB for analytics?
Yes, you can. Our customer base mostly, so far, is operational transactional systems, because that's a thing that we do so much better than most other solutions will do. But we do have customers using what we call, what I think it was Gartner coined the phrase, which is HTAP, which is hybrid transactional and analytic processing, which typically is relatively short, predictable analytic queries run in parallel. And we're doing that now, and we do have in our roadmap, I don't have time to talk about it now, some changes, some improvements in the architecture to make it easier to kind of partition part of the network to support your analytic processing and part of it to support your operational. We can separate that out now, but we're going to do more in the future to make that easier and to help you to scale up for more deep queries for analytic processing.
Okay, thank you. So I'm afraid we've run out of time. I'd like to extend a special thanks to Ian and Di for leading our discussion on application services for mobile telecoms. And thanks to you, our audience, for attending our session. We hope that you found today's conversation informative and useful. Thank you for attending. This concludes today's webinar.
Thanks, Knox. Thanks, Ian.
Thank you.
Thanks, everyone.
Bye.